Okay, so this is just a short discussion of the lab. You're going to fill out these tables with the data in on the on the sheet on Canvas. This is what the data looks like. This mass here is the mass of the stopper, and it goes here. It's little m, so it's 0.0142 kilograms. That's the same m that's in these columns. The mass of the washers is really, you probably don't need that because you took the mass. If you had you done the lab, you would have measured this mass on a scale, multiplied it by g, and got F sub c. You already have F sub c, so if you want, you can divide this quantity in newtons by g and get the mass, right? Because this is just this quantity, like for this case, it's 0.33 newtons. Divide that by g, and that'll give you the mass. But you really don't use that. What you use is this. So, so to fill out this table, this is, like I said, this is the data. You would go here and you would say, this is table 1, this data here. This is the R, so this column is this column over here. The number of turns is this column over here. The time to make n turns is here. So these 4 numbers go in these rows. And then you just calculate the velocity. The velocity is n times 2 pi r, that's in the numerator, divided by this time in seconds. That gets you a velocity. You square it, you get this column, and you multiply it by the m for the stopper, again, the m for the thing that's swinging around, and that gives you the centripetal force, or the tension in the string. Notice that inward pull is being supplied by this weight. This object has to accelerate, and so the weight should give you, this mv squared over r should come pretty close to this value all the way down the column, because this is a weight that's pulling down, and so that's what's pulling in on the stopper. And so when you calculate this number, it should approximately equal this number. Experimental error will make it not do that, but it should be close. And then, so then you fill out for each one of these tables, you fill out this number, and then you're going to draw some graphs. And so once you've got all this data filled out, then on a single sheet on a single set of axes, so print out one of the graph papers, say, plot f versus v squared for each radius. You're going to plot f sub c versus v squared for r equals 0.2 for each of these cases, f versus v squared. And so you'll have a different v squared. So you have v squared on the horizontal axis and f on this axis. And you do it for your data points for r equals 0.2 will be the first one in this column, this versus this point and that point, this point and that point, this point and that point. So you'll have 4 points, 1, 2, 3, 4 for each r. And so that'll give you 16 total points. You'll have 4 points for r equals 0.2, 4 points for r equals 0.4, and so on, right? And so you should see a linear relationship there for each one of those cases. You should see something that looks like lines with your data points. Each of those 4 data points for each r should give you a line on this graph. Again, your data should spread out over the whole chart. So you should look at, once you've tabulated all of your data, you should look at the range of the v squareds and pick an appropriate range so that it fills up your sheet, or gets pretty close to filling up your sheet. The same thing with the f sub c's. The f sub c's vary from 0.3 to 1.3, so maybe 1, 2, 3, 4, 5, 6, 7. If these are if these are 0.3 apiece, and 0.3, 0.6, 0.9, 1.2. So what if you did 0.5, 0.2 apiece? If you did these 0.2 apiece, you get 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4. That would cover the whole range. And so I would do 0.2 apiece for these guys, and then I'm not sure what the range should be to cover most of the range on the horizontal axis. with the v squareds because I haven't tabulated that data. So you're going to have two separate graphs, one for force versus v squared and one for force F sub c versus mv squared over r. So in the first graph, this is your, the F sub c's are your y-axis and the v squareds are your x-axis. In the second graph, the F sub c's are your y-axis and the mv squared over r's are your x-axis. That is all.